Hello, my name is Jari Länsi. I'm a programmer at Metosin, and this is Clojure Gently Part 2. Now, in the first part, we created a Hello World project using Eclipse and the excellent counterclockwise plugin. While we did that, we saw some terminology like namespace and symbol, and we really didn't get into detail what those meant, so I thought that this video would be a good time to do so. So the namespaces, symbols, vars and values, these are really the key concepts of Clojure, so understanding them is, in my opinion, fundamental. Here's a reminder of the code that we started with. First thing we noticed, there is a namespace declaration. We declare namespace hello.core. Now the namespaces, they are created the first time you are referencing them. Then we proceed to define a symbol hello and a function that calls the print line with the hello and n parameters. So this function was compiled and stored somewhere in memory. In some Lisp dialects, symbols are bound to values directly, but not so in Clojure. Instead, in Clojure, there is this thing called var that sits between symbol and value. So the symbols in namespaces point to vars, which point to values. The value in this case is a function body, but value can be string or number or anything. So the terminology goes namespace that contains any number of symbols which point to vars which have values. So the namespace can be thought of as a hash map where the symbols are the keys and the values of the map are the references to vars. In our source code we already also had another symbol called -main or -main, which was also contained, the value was also a function implementation, and just like with the hello, there is the var that sits between the symbol and the value. Now this version of the main was the one that was provided us by the wizard that created the project, but that's not what we were content with. We changed the code. So let's see what happens when we go ahead and change the code. So we changed the main function so that instead of calling printline directly, it calls the hello function that was provided by us. What happens in our namespaces, symbols and vars and values? Well, when we evaluate this code, the compiler creates a new function implementation which calls the hello with the argument world. Now the symbol -main is already there in the namespace, so nothing changes in there, but the var is changed so that it points now to our new implementation of the function. Now what happens to the old implementation? As you might guess, it's going to be a victim of garbage collection. So the var provides you a controlled way to introduce mutation into your application. That's not the only way to introduce mutation with Clojure, but that's the most fundamental one. Now, you can think that you could implement the whole language in a way that vars would be immutable, and you could write applications with syntax of the applications would be the same, but you could not do this interactive development, because just like we did this change, we did it on the fly so that the application was already running and we wanted to change the implementation of the main. Now this incremental way of developing applications, it's not just for experimenting, it's a very powerful way to really to do all your programming. So that in that sense the fact that vars are mutable is very important. So there's one more thing that you might notice, that there's this our implementation of hello, it also refers to symbol called print line. So as we so carelessly refer to this print line, there must be somewhere symbol print line, and indeed there is a symbol print line in our hello code namespace, but how did it get there? Well, it turns out that there is this special namespace called Clojure.core. Just like if you have done Java development, you might have noticed that you don't have to import anything from java.lang package. because everything from that package is already imported to everywhere. So the same applies to Clojure. In Clojure, the Clojure.core namespace symbols are automatically imported to new namespaces. In the Clojure.core there is a symbol print line which points to var, which has this value, which contains the function that does the actual printing. So when we created the hello.core namespace, this print line was actually imported there. So we have a symbol hello in hello core that points to this implementation that was first time defined in Clojure.core namespace. So what can we do with the namespaces besides creating them? Well, we can do two things. We can require, which basically means that you load a required namespace, and you can use, which enhances the require by also importing symbols. Let's examine them in more detail, starting with the require. Here's some fancy application where first thing we do is we declare a namespace fancy.app, and within that namespace declaration we also specify a requirement that we require a namespace universe.core. Now this is not the only way you can do requiring a namespace. You can call require directly, but it's not so common. This is the most common way, so if you read other people's code, this is the form that you are going to be seeing. So basically what this says is that declare namespace fancy.app, and while you are at it, also require the universe.core. So what happens is that you instruct the Clojure to search from the class path the namespace called universe.core, load it into memory and evaluate it. So there, now it's in memory. Then we define a symbol hello, and we declare some function that prints some answer from the universe.core. So this is how you require another namespace. As you noticed, we used fully qualified reference. These are called fully qualified references when you specify the full namespace / the symbol name. And this is the simplest way to do. This is not the only way, because we can change the code so that instead of just requiring the universe.core, we can specify an alias for it. So in here I have required universe.core, but I also said that within this namespace use an alias u for this namespace. So it's much shorter now to achieve the same result, so I can just write u/answer and it does the same thing. So this helps you with your typing, so you don't have to type so much. Now the other thing that we can do with the namespace is use. Let's write the same application, but in this time instead of requiring a namespace we use a namespace. So what happens? Well, first of all we get the new fancy app namespace. Then, as you might recall, the use implies the require, so here's the require part. Then universe.core namespace was required, loaded into memory. And then the use continues with that and imports all the symbols from universe.core into our namespace. So now that we define a hello symbol and point it to function, we can write it so that there's no, we don't have to specify any namespaces. It's the answer is a symbol that in our local namespace. Now use in this way, it really imports everything. So this is same as in Java. You might do static import using the star. So like static import static java.util.math.star would import everything from that class into your class. So the same applies in Clojure, and the same problems also apply, so that mainly that you pollute your namespace with a lot of symbols, and also that if you have two namespaces with the same symbol, you get a compiler complaining that you have double symbols. So one thing you could do in this case is go back and use the require. That's certainly one way to do it, and actually I think that that's the recommended way. But there's another thing that you can do. You can change your code so that instead of importing everything, you can specify only what symbols you would like to import. So in this way I specify use universe.core, but only the symbols that I specify in this vector. So we achieve the same, but we just limit what is imported into our namespace. So, quick recap. This is where we were left after the last video. So let's introduce the namespaces and requiring and using them with the actual live coding. First thing we need to do is create a new namespace. I create a new Clojure namespace. I call it, let's say, creator. I open them side by side, so I have easy time editing them. And I move this function hello into this new namespace creator. So now I start the REPL with the hello and load the hello.core there. And as we can see, there's a problem, unable to resolve symbol hello. So Clojure came, tried to compile this one and noticed that there was symbol hello, but that's not bound in this namespace, so this is error. So the first thing we can do to remedy this is to use require. Let's require hello.creator into this namespace, and also we need to use the fully qualified name there. Let's load it now. Okay, it loaded without any errors. Let's see if it works. Main. Call the main function and okay, it works. By the way, one common pitfall is that you try to invoke something, but you are in a wrong namespace in the REPL. So you can always check in which namespace you are by typing star ns star. There's nothing magical in this. This is a symbol star ns star, which is always bound to current namespace. So I evaluate that, and it says this is a namespace hello.core. Okay, I'm in this namespace. Good thing. Okay, let's change this by making an alias. Wrap this into vector and say that I require this as, let's say, G. So now instead of writing this long name, I can just shorten it to G. I save it and I load it into REPL, and REPL is still happy. Let's call main, and it works. Okay, this is how you require. Let's use the use. Change this to use. And now we should be able to call hello directly, because use will require this namespace, and it will also basically copy all the symbols from this namespace into this namespace. So in this namespace we should then have hello. I load it and it seems to work. Call main. Yeah, everything still works. And the final thing we did in the first part of this video was specify that we don't import everything, only, and inside this vector we say what we want. We want only hello. So let's load this one and make sure that everything still works. In this video I showed you the namespaces, symbols, vars and values, and we saw how we can play with the namespaces and the symbols. You can also interact the vars directly, but that's not very common. In the next video I will show you some data types that Clojure has, the numbers and strings, and also some collections like sets, maps and lists. So stay tuned for the next video. Thanks for watching.